Another thing we get out of this is we're centralizing the hardware resource so that the applications never talk directly to hardware. They're always talking to some trusted process. We can also, through this model, enforce permissions on the camera and the audio record so that someone can't write an application that takes, let's say, takes still images or video or records audio without the user's permission. And you've downloaded something from the market, have you written an application, there's permissions that you have to put in your manifest to be able to access either audio or video. And the user gets notified when you have an application that does that, so at least they know that your application might be taking pictures of them. The important thing for us is the disclosure. You need to understand what your application might do. As I mentioned before, the media server runs at reduced privileges. It doesn't run as root. It runs as a separate user. It doesn't have access to any of the data partition and system partition. It has to run, it basically has to get permission from another application. Media server basically has read-write access to the SD card only, but it doesn't have access to any of the files in the data partition. So if an application wants to play a data file, or play, let's say, a video file or an audio file that's in its own data partition, it actually has to open that file itself and then pass an open file descriptor. The media server can't directly access those files. So that's one way we protect it. If we allow the media server to access the data partition, then you could potentially compromise the media server and then access the user's data, but there's no way to do that here. As I mentioned before, the media server is the only thing that has direct access to hardware, and you have to have permission in your manifest in order to access that hardware indirectly through the media server. So let's talk a little bit about how potentially someone could try to compromise the media server. And I mentioned before we had this situation where the MP3 codec had a vulnerability. So let's assume that I can actually, I have a codec that has a vulnerability. And let's assume that it's actually possible to write code and write a stream that injects executable code into the media server process and tricks the media server into starting to execute it. So we have a compromised media server. Because the media server is running in another process as this user with limited privileges, the only thing that it can access is the data within its own process. And because the application is running a separate process, that means users' credit card data or passwords or anything else that might be in there is not accessible to the media server. So you may have compromised the media server, but you haven't compromised the application process data. And I think when this MP3 exploit came out, the security consultant, published this article saying how the browser had been broken, but in fact that wasn't the case. It was not possible to use the media server exploit to get the data in the browser, and that's why the sandboxing works. So, in short, no data from the application is vulnerable unless the application explicitly gives the media server permission. In the case of they've opened a file, they've passed in a file descriptor that either has read or write access. And in that case, the media server could compromise it. But you typically aren't going to do that unless it's an audio or video file, and those typically aren't something that are all that important as far as security is concerned. So quickly, I wanted to go over the Cupcake features, and then I think we'll close it out for questions. So some of the new things that we added in Cupcake are audio track and audio record in the Java interface. So this allows applications to directly access raw audio input and raw audio output. This would allow you to do things that you couldn't do before, where you can actually stream audio. So for example, you could do an internet radio application that reads audio, an MP3 stream, decodes it, and then outputs it as just raw audio through the audio track interface. Similarly, audio record now allows you to get direct access to the microphone. In the previous 1.0, you could only get access to the files after they recorded. Now you can actually get access to a live stream from the microphone. It also allows you there's a callback mechanism that supports streaming pretty well, so it calls back to the application when it needs more data. And we also made a provision for static buffers if you wanted to create sound effects. So this allows you to basically load a sound effect into memory and then just trigger it instead of having to stream from a file or something. We also introduced the JET Interactive MIDI Engine. So we have a MIDI player. The JET Interactive MIDI Engine is well suited for games. What it does is allow you to do these synchronized MIDI files. So basically, you can queue up segments of files and have it play in sequence. It's all time-stamped. You can get data back from, or callbacks from the JET engine that's timed to things that are happening in the music. So it's really good for doing like Guitar Hero or DDR type applications where you want the user to interact with the game in some musical way. We've created an open source engine. The engine is part of the Android platform. We've also open sourced the tools for creating the files. So all the authoring tools are now available. And there's a VST plugin if you wanted to generate and test files that way. So I think we're going to skip directly to Q&A here. Any questions?
有任何人想让我问一下这个一些问题吗？机会难得哦，来哦。
Hi David. I know some mobile phones have 2 cameras, right? And I traced the camera code. It seems to me camera service has the assumption that it only has 1 camera. So is framework going to support 2 cameras in the future?
Yeah, so we have plans to support 2 cameras in the future. We're starting to talk to several companies about video telephony, support for video telephony in the future, as well as things like G-Talk video. So definitely it's something we want to do. I don't think there's too much we need to do to support additional cameras. Essentially all you need is a way to create a camera, specify whether you want the forward-facing and rear-facing camera. That's definitely something we want to do.
还有人，其他人有什么想问题的问吗？对了，人从那个 Virginia 那边过来，让机会难得哦。那如果没有其他想问的话，我们就先谢谢一下 David。